Hello class, welcome back again. In this session, we're going to take a look at facts, laws, and theories, and then wrap up with a little discussion of correlation and causation. So let's go ahead and get started. So when we take a look at scientific facts, so facts are ultimately simply repeatedly confirmed observations. These are things that we have repeatedly seen in nature, we've repeatedly measured. Those things have been repeatedly confirmed, and thus we accept them as facts. Now, one of the things I want us to take a moment to think about here is, do facts change? So hopefully, as we think about science, one of the things we've talked about in terms of the nature of science is that all of science is tentative. In science, things are subject to change given new information. So I want us to realize that yes, facts can indeed change if new information arises. So let me give you a couple of quick examples of this. You don't need to know these, but something to be familiar with. If we go take a look at the medical field, before the 1980s, it was thought that stomach ulcers were caused by stress. So if you had a stomach ulcer, a part of that treatment might be a recommendation that you go to talk to a psychologist to help to deal better with stress. Where it was later discovered that ulcers were caused by a bacterium called Helicobacter pylori. And by understanding that a bacterium is responsible for it, this has ultimately changed how we approach treating ulcers to give patients better outcomes in the long run. Another example of a fact that has changed over time, if we look back some time ago, like when I was a kid, it was widely understood that Columbus was the first European to come to the Americas. Research that was done within the last couple of years has found a campsite in Newfoundland, Canada. This looking at pieces of wood that were discovered from this campsite showed that these were due to Vikings, which landed there sometime around the year 1021. So ultimately changing the facts. So again, facts are subject to change if new information arises. This does not mean that all facts will change, though. Our next concept for us today is the idea of scientific laws. When we look at scientific laws, these are descriptions of natural phenomena. We're describing the way the world behaves. Okay. Now, something that I want you to think about. You can pause the video here in just a moment. So what is the difference between a description and an explanation? So go ahead, pause the video, and think about this for yourself. Or are they the same thing? So take a moment. So hopefully you thought about that a little bit here. So realize a description is going to say what a thing is, where an explanation tells us why it is. So these are two separate things. This is saying how it behaves. This is saying why is it that way. Scientific laws are descriptions saying what a thing is. So one of the easy ways that we can often identify scientific laws is that they're often described as mathematic equations. So one such scientific law that you may be familiar with here, E equals mc squared. So this describes how energy can be, and matter can be interconverted between one another. Certainly, this idea of the conversion of matter to energy was the grounds on which we base nuclear energy. Another great example of a scientific law that we are all subject to, and that is the law of gravity. So the force of gravity is equal to the gravitational constant multiplied by the product of the two masses of any two objects. So this is object 1, the mass meaning the weight, essentially. This is the mass of object 2 divided by the square of the radius between those two objects. So at any time, if we knew your mass and the mass of your bed and the radius between you and your bed, there is a gravitational attraction between you and your bed, and we could calculate that hypothetically. So we're describing the force of gravity. How strong is that force within gravity? Now, if you're taking a course, say physics or chemistry, you're probably going to learn several scientific laws. If we look at biology, we tend to have fewer scientific laws. And one of the reasons for that is that we have biology is a very messy science. You'll notice that we have each one of these letters represents a different object or different force or factor. Biology, we have many of these factors that we call variables involved, and thus we tend to have fewer scientific laws. In fact, I don't think we'll talk about any scientific laws within biology this semester. But we do want to understand what scientific laws are. Now, big topic that we want to make sure we grasp today is the idea of a scientific theory. Now, the first thing we want to know about scientific theories is that when we use the word in science, this is not used in the same way that the general population uses the term theory. So if we look at how the general population uses the word theory, they're saying, oh, well, I've got to guess about that. Okay. So we take a look at this. You keep using that word. I do not think it means what you think it means. Great meme there from The Princess Bride. Again, people who are using the word theory typically are not using it in the scientific framework. They're basically what they're saying is that they have a hypothesis in most cases. So this is where the great shirt. I wish I could get this one. My friends keep saying theory when they should be saying hypothesis. So oftentimes on the news, you'll hear people saying, well, I've got a theory about that, when truly what they probably have is a hypothesis. They have an explanation for a specific observation as opposed to something as well understood as a scientific theory. So getting that out of the way, let's take a look at, well, what is a scientific theory? So when we take a look at a scientific theory, this is an explanation for some class of natural phenomenon. So a collection of facts and observations. So for example, a great example of a scientific theory is atomic theory within the realm of chemistry. So this idea that all matter is composed of atoms. And if we look at the way those atoms are constructed, depending on how many protons, neutrons, and electrons are present, that will alter the way that that atom behaves. So this is a theory, okay? This atomic theory. And ultimately, those different, depending on the number of protons, that will tell us why we have different elements. Things like carbon, hydrogen, oxygen. That's all covered under atomic theory. And ultimately, this explains to us why these chemicals behave the way that they do. Okay? So if you're taking a chemistry class, atomic theory is going to be extremely important to us. If we go on and take, say, in biology, one of our foundational theories is going to be evolutionary theory. So evolutionary theory gives us explanations for why living things are the way that they are. So it might explain to us, why do we have muscles attached to our ears? Why do we have a tailbone? Why do we have an appendix? Why do we have the number of ribs that we have? We can study that using evolutionary theory. So again, these are explanations for some class of natural phenomena. Again, these are our best explanations for how the world works. Now, as we take a look at these ideas, realize that all scientific theories are ultimately going to be based upon facts, laws, and tested hypotheses. And in fact, not only are they based on them, they have to be supported by those and not rejected by those facts, laws, and tested hypotheses. Keep in mind that scientific theories are indeed broad in scope. They will, in turn, propose new hypotheses in which they will make predictions. So we'll have new hypotheses arising, which we can further test those scientific theories to confirm or reject them. So ultimately, this idea that they have been repeatedly confirmed and not rejected. Now, what happens? What happens if we have a favorite scientific theory and we find facts that go against that scientific theory? Do we grasp hold of that scientific theory and hug it and never, ever, ever let it go? Hopefully we would think that's not what we do. What we have to do is we have to let that theory go and come up with a better theory that explains our facts, laws, and tested hypotheses. Now, something we need to think about. Can hypotheses become theories which can further become laws? Now, don't draw this. Many of us have been taught this. I remember being taught this as I was going through school. This idea that if we have a hypothesis and we test it over and over and over again, in time it can become a theory. And if we test that theory over and over and over again, it can become a law. Okay, kind of like that old Schoolhouse Rock. I'm just a bell. Perhaps you've seen it. If not, look up Schoolhouse Rock. I'm just a bill. It goes, I'm just a bill. Yes, I'm only a bill. And that bill is hoping that one day it becomes a law. That's not how it works in science. Realize that in science, a hypothesis is a proposed explanation for a very specific observation. Okay? Theories are broad explanations for things. Okay? So we might take a look at, if we look back at our example of atomic theory, this is going to explain why all the elements, all of chemistry behaves the way that it does, ultimately. Okay? Very broad in scope. Laws, in the other hands, are going to be descriptions for how things behave. Okay? So that's going to describe under specific conditions how certain things behave. So an explanation does not become a description. Those are separate critters. So I want us to realize, a hypothesis does not become a theory does not become a law. Just like when you were a child, you could not grow up to become an elephant. Okay? You're separate animals, separate critters. Okay? Perhaps a better way to think about the relationship of these terms is to think about, say, a three-legged stool. So here we have a theory. This is that overarching explanation, and it will explain why the laws are what they are. It will explain for us why the facts are what they are, and it will propose new hypotheses which can in turn test that theory. On the other hand, the known facts and laws must support that theory. Likewise, when we test hypotheses proposed by that theory, it also needs to support that theory. Now, let me ask you this. What happens if we discover facts that do not support our theory? What happens if we take away one leg from a three-legged stool? Hopefully you'll realize that it falls over, it collapses. And that's indeed what would happen to that theory. In this case, we would have to let go of that theory, and we'd have to come up with a new theory to explain those facts. Okay? That's how we do science. Our understanding of the world is tentative, pending new information. Now, last thing I want to touch on today is this idea of correlation and causation. So when we talk about correlation, what we're saying is we're talking about two factors that are related to one another. So one factor is related to another. There's a relationship between them. Now, the question I have for you is if two factors are related to one another, does that imply or does that suggest that one factor causes the other one to change? A poll done of the American populace, done by the Gallup Company, showed that 64% of Americans said yes, and 64% of Americans are wrong. I would like you to not be a part of that 64%. Okay? So when we see that two things are correlated, we don't want to immediately shut off our brains and say, oh, one causes the other. We need to think critically about what is the real relationship between these factors. Let me give you an example here. We're going to take a look at a set of data from the years 2006 to 2011. Shown on this graph are the number of murders that took place each of those years in the United States. And also shown on this graph is the percentage of market share held by the internet browser Internet Explorer. Now, if you look at this graph, you will immediately, hopefully, realize that there's a correlation between these two graphs. We'll see that over this time period, we had this kind of curved decrease in the number of murders in the United States. Over that same time period, we see this curved decrease in the market share of Internet Explorer. So the question is, does one of these directly cause the other? So what I'm asking you, was this decrease in Internet Explorer due to the fact that Internet Explorer users were murdered, and then as there were fewer and then over that time as more people are killed off, there are fewer Internet Explorer users? Or is this a case that as the market share of Internet Explorer went down, people were less frustrated and thus committed fewer murders? And hopefully you will realize that there is not a direct causation between these two. There is a correlation, but there is not a causal relationship between these two. The one does not directly cause the other. Let me give you a couple other quick examples here. I'm going to skip over this image here. If we look in elementary schools, there is a correlation that children with bigger feet are better spellers. So does this mean that we no longer need to give spelling tests in school? We can simply measure a child's foot and thus give them a grade in spelling? Absolutely not. What this means is that children with bigger feet generally are older. Older kids typically have more opportunity to learn more words in terms of their spelling. And so the causal agent between these is age in time, is age. So as you get older, we tend to learn how to be better spellers. As we get older, we tend to have bigger feet. So not a causation, but a correlation. Another fun example. Nations that add fluoride to water have higher cancer rates than those that do not. Now, you might see this as a headline. Perhaps you're flipping through the internet and you see, oh my gosh, look at that headline. That must mean that fluoride causes cancer. And that's a great headline. It catches your attention. right? But again, that's for people who are not critical thinkers. That's clickbait for you. Don't be a fish that bites that clickbait. What's going on here is something a little deeper. So let's think about this. What do you think about the economic capabilities of a country that can add fluoride to water? Well, if you can add fluoride to water, that means you have pretty good water sanitation to begin with. And on top of that, you've got excess money that you can put fluoride into water. That probably also means that you've got money to have a well-developed healthcare system. Thus, people tend to live longer. Now, let's think about countries that don't add fluoride to water. I mean, if your country can't add fluoride to water, you probably don't have a lot of extra money to put into that. You probably don't have as much money to put into just general water sanitation. You probably don't have as good a quality of healthcare available. So those countries that can have that money for fluoride, have that money for good medical systems, people live longer. Now, one of the things about cancer, the longer you live, the greater your risk of developing cancer. So in those well-developed countries that can add fluoride to water, great health care, you live longer, that means there's a better chance over your lifetime that you get cancer. Whereas countries that don't have money to add fluoride to water, you probably don't have that health care. You probably die of something else well before you develop cancer. So you die much younger in life. So yes, correlation, but not causation. I'm going to skip ahead here. Some other, just to get to our key points. Hopefully those are good. So as you're reviewing this, be able to compare and contrast the ideas of facts, laws, theories, and also probably throw in hypotheses. Review hypothesis. Okay, what are hypotheses? Ask yourself, if repeatedly tested and confirmed, do hypotheses become theories or do theories become laws? If you're not sure about that, go back and review this podcast. And lastly, does correlation imply causation? Again, if you're unsure about that, go back, review the podcast. And lastly, if you have any questions about this, do not hesitate to reach out and contact me so we can talk about this. Hope you have a great rest of the day. I look forward to talking to you next time.